problem 659, split array into consecutive subsequences. So for this problem, we are given an integer array, and the array is sorted in non-decreasing order. So for example, we can say 1, 2, 3, 3, 4, 5. It is an integer array nums, and it is in non-decreasing order. So we have to read the problem carefully, otherwise we're gonna make a lot of mistakes. So we're gonna determine if it is possible to split nums into one or more subsequences. So this means one or more, not two or more. It is one or more. It means at least one subsequences, such that both of the following conditions are true. So let's just check the conditions. The first condition is that each subsequence is a consecutive increasing subsequence. So we have to read the consecutive increasing sequences carefully. It is like 1, 2, 3. That is consecutive subsequences. So that means each integer is exactly one more than the previous integer. And all the subsequences have a length of 3 or more. It means the length of the subsequence should be at least 3. So we're gonna return true if we can split nums according to the above conditions, or false otherwise. So here is the meaning of the subsequence. So for example, 1, 3, 5 is a subsequence of 1, 2, 3, 4, 5, while 1, 3, 2 is not, because the order is different. The order should be 1, 2, 3, but this is 1, 3, 2. So let's analyze the example one by one, and after that we're gonna find a method to solve the problem. So the first example is that we're gonna have 1, 2, 3, 3, 4, 5. So we're gonna have two subsequences, and each of them have a length of at least 3, and each of them will be meet the first condition, 1, consecutive increasing subsequence. So let's just check. So it is 1, 2, 3, 3, 4, 5. It is consecutive increasing subsequence. So for the second example, we have 1, 2, 3, 4, 5, 3, 4, 5. We find two subsequences. Because we need to have at least one subsequence, but currently we have two, and each of them is consecutive increasing subsequence, and each of them gonna have a length of at least 3. This means it is true. So what about the third example? So maybe we can find something like 1, 2, 3, 4, and 4, 5. We find two subsequences, but the second one, the length is 2, not 3. So this is wrong. Or maybe we can find something for the third example. We can find something like maybe 1, 2, 4, and 3, 4, 5. So this is okay. 3, 4, 5. The length is 3, and it is consecutive increasing. But for the first one, the length is 3, but it is not consecutive increasing. It should be 1, 2, 3, but it is 1, 2, 4. So this means it's going to be a false. So for the example 3, no matter which way we're going to find, we can never find such conditions to meet condition 1 and condition 2. Condition 1 is consecutive increasing. Condition 2 is at least the length going to be at least 3. So it seems it's going to be a really hard problem. Even we use brute force, it's really difficult to find how many subsequences, and if we can find all of them, it's going to be really difficult. But now let's just check the second example. We're going to use the second example to find a solution. So for the second example, we have 1, 2, 3, 3, 4, 4, 5, and 5. So the idea is that while we are coding each of the number, because the array is always in increasing order, non-decreasing order, this means while we are checking this number, we will consider this number finished. We will never go back to consider this number again. So in this way, we want to solve it by just a loop. It means on time we just want to check if that is possible. So we're going to check the numbers one by one. If this number is finished, it is finished. For example, this number 2, if it is finished, this number 2 is finished. But what about we check this number 3? So if we check this number 3, we're going to check the previous number. So for example, if the previous number is going to compose a sequence like 1 and 2, while we are checking this number 3, it can become 1, 2, 3. So let's just imagine we only have 3 numbers. It is like 1, 2, 3. So for this number 1, we're gonna check this number 1 is this number 1 can become a sequence. Yeah, because there's only one number, we're gonna make it as 1. So if there's a 2, we're gonna make it as a 1 and 2. If it is a 3, we're gonna make it a 1, 2, 3. Because only in this way, this is the greedy idea to use all the numbers to make a subsequence. So it is 1, 2, 3. It meets the conditions. So if we only choose one number, for example, 1 and 2 and 3, yeah, this is not the greedy way. Yeah. So the idea is that for each of the number, we're gonna just define this number gonna be the biggest number to compose of a sequence to meet the conditions 1 and 2. Yeah. So if this is number 1, we're gonna check this number 1 gonna be the last number. So we're gonna check this number 1 gonna be a k. Yeah. So for each of the number, we're gonna check this number 1 gonna be the k, and the value gonna be defined as this number gonna be the biggest number to compose a sequence, because in this way it is the greedy idea to try to use all the numbers as much as possible. Yeah. So let's just imagine this is 1 because we only have one number. So the value gonna be an array, and we're gonna use the priority queue to check the smallest length. So currently it is only 1 because the k is this number, and the value gonna be inside this array. And finally, we're gonna use the priority queue to choose the smallest length. So the value gonna be a length. So the length for this one, it is 1, of course. But what about this number 2? So for this number 2, normally the length should be 1, but we have a number 1. Yeah. So this means for this number 1, it has the length of 1. So it is the smallest length. We're gonna choose the smallest length 1 to combine with this number 2. So for this number 2, inside the for this k is 2. So the value gonna be the longest subsequence meet the conditions 1 and 2, but this 2 gonna be the largest number, so it can become 1 and 2. So the value gonna be an array, and inside it's gonna be 2. Yeah. Similarly, we can check all other numbers. So for example, for this number 3, yeah. So what are we gonna check? So the length, yeah, if this is number 3, we're gonna check if we can combine it with number 2. For this number 2, it can combine with 1 and 2. For this 3, it can combine maybe with 1, 2, 3. So luckily for us, we're gonna have a 2. We're gonna try to use this 2 because we want to make the length more than or equal to 3. Yeah. So if this is smaller, this is 2. We're gonna make it a 3. So for this number 3, it is the largest number, and it can become a sequence of 1, 2, 3. So this means we're gonna use this 2, and currently the length gonna be 3. Yeah. But while we are checking, as we can see, for this 1 inside it is 1, for this 2 inside it is 2. But while we are checking that, we're gonna pop all those numbers out. Yeah. So this is the meaning why we're gonna use priority queue to solve the problem. If we pop it out, it's gonna become empty because we're gonna use this length. Yeah. Because this means this one has already been used, and this 2 also has already been used. So this is gonna become empty. Yeah. Now we're gonna continue to check. Yeah. So this 3 is finished. Now we're gonna have another 3. Yeah. Because this is another 3. So this is gonna be the k. Yeah. But do we have a number 2? Because this number 2 has already been used. Because we don't have this number 2 again, because we have already used, because so this means inside the array for this k2 and for the priority queue inside this array, it's going to become empty. If it is empty, what's going to happen? Yeah, because we found this 3, so adding with the 3, we have 1, 2, 3. Now we have another 3, adding with 3, there's nothing. So this means the length is going to become 1. So we're going to put a 1 here inside the priority queue. So we're going to continue to check. So now we have a number of 4. So if this is a number 4, what's going to happen for us? We're going to pop out the smallest number. Because we want to keep a balance, we want to keep the length as much as longer if this is smaller. For example, this is 1. definitely we want to make a 1 plus 1 become 2 instead of a 3 plus 1 become 4, because we want to make a balance. We want to make it as longer as possible, because currently this is 1. So for this number 4, we're gonna pop out this 1. This means this 1 gonna be popped out. Yeah. And if this 1 is popped out, this 1 plus 1, so for this number 4, adding with 4, we're gonna have a length of 2. So currently we've already checked this number 4. Yeah. Now we're gonna continue to check. So if we find this number 4, what are we gonna do? Yeah, we're gonna still pop it out because there's still numbers 3. So this means this gonna become empty, and this gonna become 2 and 4. Yeah. So here gonna become empty. Now we're gonna continue to check. Yeah. Now we have this number 5. Yeah. So if it is adding with 5, we're gonna pop out the smallest number. It is 2. So this 2 means 3 and 4. So 3 and 4 gonna become a 5. 3, 4, 5. So this means inside of the priority queue, it's gonna be a 3 and 2 is popped out. Yeah. Now we're gonna continue. We have another 5. So this means this 4 will be popped out, and inside of the priority queue for this K5, it's gonna be have another 5. It's gonna be 3 and 5. Yeah. And this 4 will be popped out. Yeah. So currently what's left behind? And this is all the case like 1, 2, 3, 4. It is empty, but this is 5. So for this K5, we only need to check the smallest number 3, because if 3 meets the conditions, definitely 5 meets the conditions, because 3 and 5 is just the consecutive length. This 3 means 3, 4, 5. This 5 means 1, 2, 3, 4, 5. So definitely this meets the condition. It means we're gonna return a true for the second example. Yeah. So for this 5, if this is not 3, if it is a 2, definitely we're gonna return a false. Yeah. So this is the idea to solve the problem. Yeah, it is a difficult problem, but if we can think about it in this way, we're gonna use a priority queue, and we're gonna check all the numbers gonna be the k, and the value gonna be an array of the length of the subsequence, which meets the conditions 1 and 2, and this number gonna be the biggest number. Yeah. We're gonna check the longest subsequence adding with this number. Yeah. Now the idea, it seems becomes easier. So we're gonna use a default dict, and inside it's gonna be a list. So this dictionary, for the value, it's gonna be a priority queue, and for the k, it's gonna be each of the number. Yeah. So we're gonna check the numbers one by one, and we're gonna check the previous number if not d n minus 1. So we have to use if not dn minus 1, because for the k and value, the value should be, if it is an empty array, we still need to check that. Yeah, we cannot use if n minus 1 not inside d. We cannot check it like that. Yeah, because for the default dictionary, the list can become empty. We still need to check the empty. We cannot use it this way. We have to use if not d n minus 1. It means it's gonna be an empty list for this k n minus 1. Yeah, if it is empty, we're gonna build it. For example, if the first one it is a 1, so we're gonna build it. Yeah, how can we build it? We're gonna use a heap push, and for this k, it's gonna be dn, and for the value, we're gonna push a value. The length is gonna become 1 because it's gonna be the first number. Yeah, otherwise, if it is inside, first of all, we're gonna check the minimum length. So the minimum length is gonna be a heap pop. Yeah, so we're gonna pop out from the dn minus 1, and this is gonna be the minimum length. It means the previous number. Yeah, so we're gonna pop out the previous number, and we're gonna push it inside. Yeah, so for this one, it's gonna become it's going to become dn, and the minimum length plus 1. Yeah. Now let's just check what is inside of the dictionary. Maybe you just wonder. Let's just give a random true. Yeah. So let's just check what is inside of the dictionary. Let's just check the second example. We can see the second example for 0, 1, 2, 3, 4, 5. It is 3 and 5. This is exactly what we calculated before. Yeah. And for this 0, it is an empty array. This is also okay. Yeah, because for our check, if we are using this line, if dn minus 1, if the first value is 1, it means we're gonna check D0. Because for D0, there's nothing, so we're gonna, for the default date, we're gonna prepare an empty array. Then that doesn't matter. Yeah, for our calculation, that doesn't matter because it is empty. Yeah. So finally, we just need to check the dictionary. So for k value in d.items, yeah, if there is array and the first number, it means the smallest number of the array is less than 3, definitely it's gonna be a false. Otherwise, we're gonna return true. Let me just run it. As you can see, it works. Now let me just submit it. Yeah, as you can see, it's possible all testing cases, and it's pretty fast. So the idea is really difficult, but the coding is easy. Yeah. So the idea is that because there are so many numbers, we try to use them as much as possible, and we want to keep a balance of at least 3. Yeah. So this means by using a priority queue, and for each of the number, we're gonna set it as the largest number inside of the sequence. This means we just need to check the previous number. Yeah, if the previous sequence is shorter, like 2 and 4, we're gonna try to use the smallest sequence because we want to make it 2 plus 1 becomes 3. Instead of, yeah, we want it to make 3 and 4. So instead of like 2 and 5. Yeah, because 3 and 4 meet the conditions. 2 and 5 didn't meet the conditions. We want to make it as longer as possible, and we want to make it as equal as possible because 3, 4 is closer. Yeah. I think that's all about it. Thanks for watching. See you next time.